In the beginning, you mentioned envelope encryption. Could you elaborate on that a bit?
Yeah, envelope encryption is the technology that we're using here. So the whole idea that we have this data encryption key, which is then encrypted with a key encryption key, which is then encrypted with a master encryption key and a root encryption key, etc., etc. So we're having these kind of envelopes within each other, a little bit like a Russian doll type of a system. There's a pretty good article on envelope encryption on Wikipedia. You should definitely read that to get a little bit more
We'll put a link.
Yeah.
Okay. Thanks. You also talked about key rotation. What does that mean in practice?
Yeah, it's a good question. So starting off with the Google managed system, in that case, we have this rotation interval of 90 days. And the idea here is that we're not using the same key to encrypt everything, because that might lead to security problems over time. So with Google managed keys, we are having this rotation schedule of every 90 days. And then what actually gets rotated is we're creating a new key, and then we're using that for any further encryption. Now, stuff doesn't get re-encrypted until we're like 20 versions deep in these versions of the same kind of key, right? So instead of just always re-encrypting everything, we're basically just saying that as long as we have had the data encrypted for less than roughly 2 years, we're happy that we're keeping one of the versions that was used for encryption in that kind of key ring. And and all of this, of course, happens totally transparently to us. So the re-encryption process every 2 years happens and is totally managed by Google. We don't even see that happening. And it's really hard for us to even say what's going on, because we don't really see the keys either. So we're kind of relying on Google's documentation at this point to kind of know how the system works.
So, but why not just re-encrypt everything at once? Like, why bother keeping the 20 versions of it?
Yeah, well, you can think about that with the kind of gigantic volume of data that Google has. So if Google would actually be re-encrypting all of the data that they're handling every 90 days, then that's pretty much the only thing they would be able to do, right? There wouldn't be any compute power left for us to use for virtual machines or anything like that. So the idea is to lessen the possibility of key leakage by rotating the key, but then simultaneously keeping the effort required for re-encryption as quite minimal. So, and this is the same strategy is used by other cloud providers as well. So this is kind of a mid-ground where everybody figured out that that's probably best for security.
Okay. If I opt for customer-managed keys, then what do I need to manage?
Yeah, it sounds like you're managing something when it says customer-managed keys, right? Mm-hmm. Well, in practice, with customer-managed keys, you still don't have any access to the key material, right? So basically, the keys are living in a key management system, and it's your job as a customer to create a key, to manage the permissions for that particular key, and then to rotate those keys manually. So with customer-managed keys, there is no automatic rotation at all. You will need to take care of that. Simultaneously, you're also responsible for re-encrypting the data in case you're deciding to remove one of those older keys that you haven't been using for encryption for a while anymore. So, but we're going through this in the practical parts of the course. So you should just review the video where we're doing a re-encryption.
And you could be rotating the keys at your own pace, like for every 30 days or like once per week even?
Yeah, so the reason why people would use customer managed keys would be that they have a compliance reason for that, right? Or a permissions requirement. So what really happens or when this really gets used is if your compliance data says that you need to rotate your encryption keys every 30 days. And now the Google managed keys rotate every 90 days. So you can't affect that in any way. The only way to be compliant within your compliance system is then to use a customer managed key and manually rotate that every 30 days and then re-encrypt accordingly, right? The other reason would be the permissions issue, right? So now if you're using customer managed keys, the read access to an object is actually the combination of both having read access in Google Cloud Storage and then having the decrypt permission on that key that is managed within KMS by you.
Is there a best practice for this key rotation if you need to do it yourself? Is there a best practice how to do it? Like in reality, how would you do it? Not how would you do it, but is there like a guideline or something from Google?
I don't really know of a kind of best practice approach. I guess we can use the rotation schedule created by Google as a kind of a gold standard because they're really serious about security. And if Google thinks that rotating key every 90 days is secure enough for anything, basically, then I guess we have to go with that. But like I said, you might have some local compliance issues that require more frequent rotation than that, and then that's what you need to go with.
What I actually meant was that when you need to do it like for every 30 days, so are there like instructions, what the steps how to do it, or would you just hack it?
No, we're going through the steps on how to rotate a key, and then also how to re-encrypt the data in the practical videos. So
okay. So we're getting there.
Yeah, just
right.
Take a look there.
Thank you. Okay, what if I opt for customer supplied keys? What happens if I lose them? Can I use brute force or am I lost?
Yeah, good question. Short answer, you're lost. Longer answer, because when you're using customer supplied keys, that basically means that there's no copy of the key left on Google servers after the transaction has completed, right? So what you're supplying is the key encryption key, right? And that's what's being used to encrypt the data encryption key. So what happens if you would try to retrieve the data with just a random key? Would you get back the ciphertext and then be able to somehow brute force that encryption? Short answer, no, doesn't work. Longer answer, when you do provide the key for encryption, Google Cloud saves a hash made from that key material. And then when you're trying to read back the data, it will compare the key that you're providing with that hash. Otherwise, and then just not allow any data to be retrieved unless that matches. So then you're basically attacking the hash algorithm here. And
through the API.
Yeah, through the Google Cloud Storage API, that will probably throttle you quite quickly. So in practice, it's not going to work. So basically, the only thing that you can do with the data at that point is delete it and not get charged for it anymore.
So no brute forcing.
Yeah, there's no access to the ciphertext at all.
Okay. And once again, what is the difference between customer managed keys and customer supplied keys?
Yeah, I guess the difference comes down to where the keys are located, right? So with customer managed keys, you don't get access to the key material at all. The customer managed keys are within a key management system. There are different types in Google Cloud. You have the option of using a shared hardware cloud key store or your own dedicated hardware module. That's possible as well. However, you will never be able to see the key material for the key encryption keys. If you're using customer provided keys, it's the other way around, right? So you are the only person or organization that has access to the keys, and you need to provide them to Google Cloud Storage to do the encryption and decryption at all times. Of course, this is only a viable option if you have something like a hardware security module on premises, which you use to store those keys so that you won't actually lose them, right? And that's, for me at least, that's the only reason when you would be using keys support, provided by the customer. And this might also, again, be due to compliance, right? So you might have compliance reasons that you cannot use a key store that is not physically under your control. And as we know, within Google Cloud, we cannot physically be in control over any of the hardware there, right? So compliance might say that you need to be physically in control of the key material, and then that kind of boils down to you having on-premises hardware security modules which will then store that key material, and then you would use it when encrypting and decrypting with cloud storage as customer provided keys.
So why wouldn't you just encrypt the data yourself?
Yeah, good question. That's something that you could do just as well here. However, if you're doing encryption of the data yourself, then you are responsible for making sure that the encryption process is proper, right?
Which is hard.
Which is hard. So, of course, you were going to use a crypto library that is well known, and et cetera, et cetera. So it might be easier to just externalize that over to Google Cloud Storage. And if you're doing it with Google Cloud Storage, remember that there's no charge for encryption. So you don't need to pay for those extra CPU cycles like the actual encryption. So if you get it for free, then why would you do it yourself?
Good answer. Thank you, Johannes.
Thanks.